Hey guys, good morning or good afternoon, whichever it is for you. Today I am going to go over the worksheet that you had on the trig identities. After we go over the worksheet, then we're going to start looking at solving trigonometric equations. But just a reminder, tomorrow, Friday, we will have a quiz on the trig identities. Okay, it'll be just a short quiz, be like 3 problems. Okay, so the quiz will be just like this worksheet. So let's take a look at it. Okay, so number 1 on your worksheet, we had secant x over sine squared x equals cosecant squared x over cosine x. So there's a couple things I want to point out here. Okay, we're trying to verify the identities, which means we're trying to show that the left side of the equation is equivalent to the right side of the equation. We are not solving the equations. So we have to resist the temptation to treat it like we're solving it. And what I mean by that is we don't want to do things like cross multiply or add or subtract from both sides, right? We're going to work with one side at a time. And our goal is to get the left side to be exactly the same as the right side. Okay, so looking at this one, my first thought is to rewrite that secant. So secant is the same thing as 1 over cosine. Okay. So what we typically do is we work with one side at a time. We don't go back and forth, okay? So working with one side at a time, I'm going to rewrite this as 1 over cosine x times 1 over sine squared x. Okay. So let me just move it up here. So right now I have 1 over cosine x times 1 over sine squared x, and that equals, at least we hope it equals, cosecant squared x over cosine x. Okay, well at this point I'm doing pretty good because I have the cosine x part in the denominator. I've got to work on getting this sine squared to be a cosecant squared. Well, that's one of our identities. 1 over sine, right? One of our identities, let me see where I can put this so that it's not in the way here. Okay, we know that 1 over sine is equal to cosecant. Okay, so we're going to rewrite this one as we've got 1 over cosine x times cosecant squared x because of that identity that we have. So sure enough, now we have cosecant squared x over cosine x, and that equals cosecant squared x over cosine x, and we've proven our identity. There are a number of ways that you could have done this. We could have started on the right-hand side, and we could have worked with that, okay? Because we know that cosecant squared is 1 over sine squared, so we could have worked with that, okay? All right, let's look at the next one. So the next one we have tangent x plus secant x over secant x, and that equals sine x plus 1. Okay, so usually we're going to try to work with what looks like the more complex side first. So to me, the left side looks more complicated. So let's see, let's change the tangent. Let's change that to sine x over cosine x. And let's change the secant to 1 over cosine x. Okay, and we'll just kind of keep going with it this way. And then here we have 1 over cosine x down there. Leaving this side alone, okay? Okay, so up here I have a common denominator. So if my common denominator there is cosine x, so on the top I have sine x plus 1. Well, we're getting close, because that's actually what I want. I just want the sine x plus 1. All right, so what if now we flip and multiply? We're going to flip and multiply this, right? So we're going to multiply times cosine x over 1. Okay, so that means now I have, my cosines are going to cancel. So now I have on the left side sine x plus 1, and that equals on the right side sine x plus 1. And we're finished. Okay. Alrighty. Let's move on to the next one. Tangent squared x over sine squared x equals 1 over cosine squared x. Okay, once again, I'm going to start on the left because that looks to be a little more complex. So, let's see. I'm going to change the tangent to sine squared x over cosine squared x. Okay. And then I'm going to flip and multiply. Remember, this is over 1, right? So we're going to go ahead and flip and multiply. So sine squared x over cosine squared x times 1 over sine squared x, right? Then we can go ahead and we can cancel these sine squares out. And we're left with 1 over cosine squared x equals, sure enough, 1 over cosine squared x. Boom, we're done. Okay, look at another one. Now they're getting a little bit harder. Cosecant squared x plus tangent squared x equals secant squared x plus cotangent squared x. I mean, I'll be honest, when you look at that, it doesn't look like they're equivalent, right? So let's see, I've got lots of secants and tangents and cosecants and all that stuff. So there's a couple different ways we can approach this. One way is to change everything to sines and cosines. But before I do that, I want to explore the Pythagorean identities. So let me just refresh your memory. Sine squared x plus cosine squared x equals 1. Okay, so from there we got a couple other identities. We said that this means also that tangent squared x plus 1 equals secant squared x. So that one's promising, right? And then we also said that 1 plus cotangent squared x is equal to cosecant squared x. Okay, so I think I want to try to work with these and prove the identities from that direction. So let's see, cosecant squared. Cosecant squared is the same thing as 1 plus tangent squared x. I'm sorry, not tangent, cotangent. Sorry about that. Okay, and then we have plus tangent squared x. I don't know if that's going to help me or not. Yes. Okay. So do you see it? It just kind of jumped out at me. Let me move down here where I have more room. I have 1 plus cotangent squared x plus tangent squared x, right? So I'm not going to substitute in that tangent squared x. I'm going to work with the other side now. And what does secant squared x equal? Well, look at that. Secant squared x is tangent squared x plus 1. And then I have plus cotangent squared x. So I have everything that I need. I just need to rearrange them. So I can rewrite this as tangent squared x. So I'm just going to move that over. Plus 1 plus cotangent squared x. And we have our identity proven. Okay, that was kind of it was a little bit tricky. These are challenging because you're just not familiar with the Pythagorean identity. Okay, and I know that it takes a little bit of work and effort to come up with these, but it is very important that you can do it. I don't have these memorized. I have this one memorized. Right? Then if I divide by cosine squared, I get tangent squared, I get 1, and I get secant squared. If I divide everything by sine squared, I get 1, cotangent squared, cosecant squared. Okay? So I don't have them memorized. I just figure them out. Okay, let's see if we can do this using a different method instead of the Pythagorean identities. Because the reality is you may miss that. And it's going to take a little more work, but we should get to the same result. So what I'm going to do is I'm going to get everything down to sine and cosines. So cosecant squared, that's going to be 1 over sine squared plus tangent is sine squared over cosine squared. Okay. And then let's look on the other side. This is going to be 1 over cosine squared. And this will be cosine squared over sine squared. Okay. So what we're going to do here is we're going to get a common denominator. The common denominator will be cosine squared x and sine squared x. That's our common denominator. So that means I need a cosine squared x here, all right? So we're going to have cosine squared x over cosine squared x sine squared x plus, see, it does get ugly, doesn't it? Okay, so this will be, we have to multiply by sine squared, so this will be sine to the 4th x over cosine squared x sine squared x. So that's going to give me cosine squared x plus sine to the 4th x over cosine squared x sine squared x. Okay, now we're going to work with the other side, and we're going to do the same thing. We're going to multiply by sine squared, so sine squared x over cosine squared x, plus, and we've got to multiply by cosine squared, so that's cosine to the fourth x over sine, sine squared x cosine squared x. I forgot to write that here. So we have sine squared x plus cosine to the fourth x over sine squared x cosine squared x. You see how we're kind of going down a rabbit hole here? This is not pretty at all. All right, so what's our problem now? Yeah, looks to me like, did I make a mistake somewhere? Yeah, this is ugly. This is just kind of spiraling out of control. So here it turns out I'm still going to have to use my Pythagorean identity and substitute in. I'm going to have to substitute in for my cosine squares or my sine squares. So this is really going to get nasty. So here I thought I could show you that you could do it either way, but this is just not a pretty thing. So we're going to say forget this because it's much too complicated to do it that way. So this is a good example of what I was explaining to you yesterday, right? Here we are trying to get to our cabin in the woods, and there's, 3 different trails, okay? And we have to pick which trail, right? Sometimes we pick a trail, and as we follow it, it just starts winding and really getting messy and difficult. So when that happens, we go back and say, you know what, I'm going to try a different path. And there's a more direct path. So this is a good example of that. Sometimes it just gets so complex that it's just like, you know what, let's go back and let's start fresh and see if we can find a better path to get to that answer. Okay, the last one on your homework was sine x plus cosecant x equals 1 plus sine squared x over sine x. Okay. All right, so this time I'm going to work with the right side. Okay, and what I'm going to do is I'm going to separate these. I'm going to rewrite this as 1 over sine x plus sine squared x over sine x. Now, when I do things like that, I always like to double check, like go back again. Say, okay, if I started with this, would this combine to equal that? And yes, it would. Okay. So now that we've done that, actually it looks pretty nice and simple because I know that 1 over sine, that is cosecant x. And then here, my sines will actually reduce and I'm left with sine x. So we can change the order that we write that, sine x plus cosecant x. And that equals sine x plus cosecant x. And we're done. Okay. I know these are scary because I can't give you a definite rule every time. You really just kind of have to work with it. If it starts to spiral out of control and get too complicated, then I'd say go back to the start and try a different path. Okay. So on Friday, tomorrow, we will have a quiz on the identities. And there's only going to be like 3 problems. And then you'll have a worksheet on solving trigonometric equations. So we're going to take a look at that right now, actually. Okay, so as I was preparing to go over a couple problems with you, I decided I'm going to I'm going to actually let you listen to, oh my goodness, I just lost my train of thought. I'm going to actually play the video from the first period class that we had today, where we went over some additional trig identity problems. And that way you'll feel a little bit more prepared for tomorrow. So we've got about, we should have time. We've got about 30 minutes of this video plus the 20, so we should be good. Okay, so I'm going to actually, hopefully this will work. I'm going to actually play the video from the remainder of today's class, from first period's class, so that you'll be in the same spot, okay? And these can get very complicated, but we're not going to because we need to move on. Let's do cotangent x times secant x times cosecant squared x equals 1 over sine to the third x. Try that one. You can do it any way you like. You can write on your leg if you want to. Okay, so what should we do? Good. Sine, not secant. Cosine. Cosine x over sine x. Okay. And then we'll change the secant to, oh. Okay, so we'll change the secant to 1 over cosine. And we'll change the cosecant squared to 1 over sine squared. Okay, we're leaving the right alone. So then we see that the cosines cancel. And we're left with 1 over sine times sine squared, so that's sine cubed. And that equals 1 over sine cubed. And we're done. Okay, one more. One more. Okay. How about this one? 1 over cosine squared x equals tangent squared x plus 1. Yes. Which side are we working with? We could do both, but you could do one also. The right side? What did you do? Yes. Tangent squared x plus 1 is secant squared x. And then secant squared is 1 over cosine squared. Boom, we're done. You're not going to have your notes to refer to. You have to know your identities. That's the hardest part, recognizing them. Okay? Yes? Correct. That is correct. It's the plus 1. And remember, that comes from sine squared x plus cosine squared x equals 1, right? So what we did is we said, oh, let's divide everything by cosine squared. So it all comes from that basic one. So this is going to be tangent. And then we have plus 1 equals secant squared. That's where it comes from. Okay. Okay, so your quiz Friday will be on this. There'll only be like 3 of them. One more. Come on, guys. We got things to do. Come on. No, we got more to do. I'm going to solve equations. Last one. Yeah, see? Okay, which side do we start with? How many started with the left? How many started with the right? Yeah, I started with the right. You could do the left, but I think it's easier doing the right. Okay, what's cotangent? 1 over tangent squared. Now, there are several ways we could do it. We could change everything to sine and cosines, but in this case, you can kind of see it's a lot easier not to do that. What's cosine? 1 over secant. So while I'm doing that, I'm looking at the other side to make my decisions. So now I've got 1 over tangent squared secant x, and that equals 1 over secant x tangent squared. And that's all you have to do. Okay. Now, we could have done it by changing everything to sine and cosines. So for instance, let's work with the left side. This is going to be 1 over cosine times sine squared over cosine squared, right? Which gives me 1 over sine squared over cosine cubed, which equals cosine cubed x over sine squared x, right? So now I need to go work on the other side. It's so much harder, right? Working on the other side, cotangent squared, that's going to be cosine squared x over sine squared times cosine x, which equals cosine cubed x over sine squared x. So we could have done it that way also. Okay, but it was a whole lot easier. So when I was deciding where to start, I was kind of looking at this side as I was working this side. Because normally we wouldn't change the cosine, we'd leave that alone. But I recognize that cosine is 1 over secant. So because of that, I changed it. Okay. Okay, so there'll only be like 3 questions on your quiz, but we need to move on. Okay. The biggest challenge for you will be memorizing those identities. When you recognize the identities, it's actually pretty easy. Okay, so we're going to move on to solving trigonometric equations. The identities, okay? So let's say, for instance, that we have 2 sine x minus 1 equals 0. I want you to solve for x within the domain of 0 to 2 pi. The reason I'm specifying that is that, remember your unit circle, right? Once we go all the way around once, right, I could keep going. but I'm not going to get any new answers, right? I could just keep going and keep going and keep going. So to start with, we're going to specifically tell you just to stay within 0 to 2 pi. Okay, so we're trying to solve for x. So what would you do first? Add 1, and then divide by 2. Okay. Now we want x by itself. So that means we're going to take the inverse sign. So x is equal to the inverse sign of 1/2. Remember, that is not 1 over sign. Okay, the inverse sign is not 1 over sign. So it's the inverse sign of 1/2. What that means is that I want to know which angle, right? X is referring to the angle. Which angle gives me a sine value of 1/2? So we have to know our unit circle. Which sine value gives me, which angle gives me a sine that's equal to 1/2? How about 30? Okay, so x is equal to 30 degrees. What else? What about over here? This is negative √3 over 2, comma 1/2. Does that work? Okay, what angle is that? 150. How about down here? Is that one going to work? No, because it's negative 1/2, right? How about over here? That doesn't work either. So we get 30 and 150. So, but if you notice, our domain was in terms of radians, so we have to change this to radians. So x is equal to pi over 6 or 5 pi over 6. And that's our solution. Okay. I'm going to show you this on the graph. Okay. All right, so we've got 2 sine x minus 1. I'm going to graph it in radians. Okay, and we'll leave it from -4 to 4 because I know enough about my function. What's the amplitude of this? 2, right. So if I know if I go from -4 to 4, I'm going to be okay on the y-axis. On the x-axis, we're going to go from 0 to 2 pi, because that's what they said my domain is. And I'm going to make the scalar, I'm going to make it pi over 6. Because when I solved it manually, pi over 6 was one of my answers, right? So what am I looking for when I graph it? I'm looking to see where 2 times sine x minus 1 is equal to 0. How am I going to see that on the graph? Yeah, it's the x-intercept, okay? Oops, I have to change my mode. Okay, so look, when I graphed it, that's clearly not a sine curve, right? We have to know something about the function we're graphing. So I know that there was a mistake there because it's like, oh, that's not a sine curve. So I've got to change my mode to radian. Okay. Now I get a sine curve. Okay, each mark represents pi over 6. So sure enough, pi over 6, 2 pi, 3 pi, or 4 pi, here's 5 pi over 6. So it's going to cross the x-axis in 2 places, pi over 6 and 5 pi over 6. Okay, those are the 2 angles that give me the correct answer. Okay, everybody got that? All right, let's do another one. Let's look at, okay, how about sine x plus √2 equals negative sine x. And we're going to work again 0 to 2 pi. What do you think? We're trying to solve for x, so what do you think we should do? Not yet. If it was just x plus root 2 equals negative x, what would you do to solve for x? We would add x to both sides, right? We've got to get the variables all on the same side, guys, right? Come on. Don't forget your basic algebra, right? If you're solving for x, you've got to get all the x's to one side. So we're going to add sine x to both sides. Okay, so that gives me 2 sine x. Then what? Then what, Anthony? Yeah, subtract the radical 2. Kobe, what now? You guys finished having your little powwow? Yeah. Use your own brain. Guys, let him use his own brain. He can do that. That's nothing to struggle with. He can do that. Okay, so that means that we're taking the inverse sine to get the x by itself. We're taking the inverse sine of both sides. Okay. So now we have to figure out where that is. Okay, so look at our unit circle. Sine is the y value. What angle gives me a y value equal to negative root 2 over 2? Okay, so 45 is not going to work. Well, 135, will that work? No, because that's going to be positive. Down here at 225 or 315. Now we have to convert those to radians. Okay, so this is pi, right? Or 4 pi over 4. So what's this one? 5 pi over 4. Then we have 6 pi over 4, and then this is 7 pi over 4. And there's our answer. Okay. Now, if we do this on our calculator, it can help us, but we have to be careful. It's going to give us a weird answer. I think it's actually going to give us negative 45 as an answer. But let's check it out, right? I'm going to put myself back in degrees. Okay. So I'm going to do inverse sine of negative root 2 over 2. Okay, and sure enough, that gives me negative 45 as an answer. So we can't rely on our calculator. That is not incorrect. Negative 45 brings me here. I have to learn to read the answer the calculator gives me and then interpret it. But it's only going to give you one of the answers. So the good thing is it gives you that reference angle of 45 degrees. But you have to figure out what the actual answer is from that, okay? So looking at the other reference angles of 45 degrees, you have to figure out which one actually works. It's these two, okay? Not too bad, right? Okay, let's just go back and look at this one, okay? So I specifically asked you to solve it using a domain of 0 to 2 pi. Well, if I did not restrict the domain, right? If I didn't restrict the domain, just get this out of my way here. Okay, my answer would be right here and then right here. But if I go all the way around the circle, right, there's 2 pi. I could keep going. Again, let's do it in degrees because it'll make more sense. Instead of 30 degrees, I could say 390 degrees. 390 degrees is going to bring me to the same spot. Okay? Or I could say 750 degrees. It's going to bring me to the same spot. Okay? Okay? I could keep going. If I did another 360, that's going to be what? 360, 10, 11, 10. Right? I have infinitely many angles. So the way we represent that answer, if there is no domain restriction, every time we're adding another 360. So I'm just going to work in degrees first. So we would say 30 plus 360K. K refers to how many times around I'm going. So if I don't go all the way around, K would be 0, so it would be 30 degrees. If I go around once, it would be 30 plus 360. If I go around again, it's 30 plus 360 times 2, right? This number refers to the period, okay? So in radians, we would say pi over 6 plus 2 pi k, indicating that I can keep going around and around and around depending on the value of k. So how would I express this other answer? 5 pi over 6 plus 2 pi k. So when we do not have a restriction on the domain, we have to write the answer like that to include all possible answers. Does that make sense? So we would have 2 answers here. One of them would be pi over 6 plus 2 pi k, and the other would be 5 pi over 6 plus 2 pi k. Those would be our 2 answers. Okay? Okay, how much time we have left? Oh, wow. We got lots of time, man.
Let's go for
Lots and lots of
we have
time.
to test the tree. We have to test the tree. It's not fair.
They're gonna bring back that.
It's a new tree.
Sorry, please look at it.
Oh,
It's right where the chocolate.
Pi.
First one.
And then you can check it on your graphing calculator. Okay, so the first one is very similar to what we already did, right? So we're going to add 1, so we get 2 cosine x equals 1. So cosine x equals 1/2. So x equals the inverse cosine of 1/2. Excuse me. So, and we could even use our calculator to help us if we wanted to. Inverse cosine of 1/2. And it's going to give us 60 degrees. So that gives us our starting point. That gives us our reference angle. 60 degrees is one of the answers. So look at all the other 60-degree reference angles. Here, here, and here. So 120, does that work? The x is going to be negative there, so 120 doesn't work. So we're looking at x equals 60 degrees. How about down here at 240? Does that work? No, because the x is negative. How about at 300? Does that work? Yes. Okay, so now we have to change them to radians. So this 60 degrees is pi over 3. And 300 degrees is, what is that, 5 pi over 3? You got me questioning myself. Let me double check and see. Pi over 6, 2, 3 pi, 4 pi, 5 pi over 6, 6 pi, 7 pi, 8 pi, 9 pi over 6, 10 pi over 6, which is 5 pi over 3. All right, there's our answer. Okay? All right, next one. We've got the square root of 3 times secant x. We're going to add 2 to both sides, so that equals 2. Dividing by root 3, we get 2 over root 3. Now, secant is a reciprocal of cosine, so I can write this as 1 over cosine x. So what can we do from there? Flip it. This means that cosine x is equal to root 3 over 2. We can just flip it. Okay, yeah.
Now, could you leave it in the secant if you know that it's a cosine?
Yes.
How it's like the 2 over x, but
Yep.
like you know it's flipped.
Sure can.
So I wouldn't have to write all of that out.
No, you don't have to. If you know the secants. Okay. Okay, so we're looking on the unit circle. Where is the cosine equal to root 3 over 2? Right here at 30 degrees, or pi over 6. And then again over here at 330 degrees, which is 11 pi over 6. Okay. You have to know your unit circle. If you don't know your unit circle, this is difficult. I know you haven't heard me say that before. You have to know your unit circle. Okay, last one. Cotangent x equals -1. So x equals the inverse cotangent of -1, right? So cotangent is x over y. Where is that equal to -1? Well, it's not going to be in quadrant 1 because they're both positive, so we'd get a positive. It's over here in quadrant 2. It's not going to be in quadrant 3 because in quadrant 3 they're both negative. So we're looking at 2 and 4. So where the x over y is -1. So this is going to be at 135 degrees or 3 pi over 4. And at 315 degrees or 7 pi over 4. And there we go. Okay? Questions? Okay, we're going to stop there. I will not be here tomorrow or Friday because of a conference. So you'll have your quiz and then you'll have a worksheet to do on solving the trigonometric equations. Okay? All right.